right, we are live again. Welcome everybody to Push to Prod. We are in day 2, and I'm extremely excited about the group of folks that we've got here today with us. My name is Eric Wright. I'm going to be your partial host for this amazing panel. We've got a lot of great content, and we've got a real good interactive opportunity as well. So without further ado, I wanted to introduce the folks who are going to be sharing with us today. First of all, coming at us live from across the world, 10:30 your time in the PM. Lohit, if you'd like to introduce yourself and tell us your role, and then we'll also move through to Daniel as well.
Yeah, sure. So hi everyone, this is Lohit here from the IBM company, and I'm in the India time zone at this point. So I'm a senior cloud architect working primarily around the Red Hat technologies. And in my role, I do work with a lot of clients, a lot of products, offerings, and then try to give a lot of Red Hat focus at this point. I've been with IBM the last 16 years.
Excellent. Well, thank you, Lohit, and again, thank you for the joys of live events that are in worldwide time zones. So forget about follow the sun; we follow the action. So with that as well, Daniel Aubert, or say, I hope that I'm saying it, my French Canadian comes out. Daniel Aubert, welcome to the broadcast. Daniel, if you'd like to introduce yourself and tell us about your role and what we're going to talk about today.
Well, you actually pronounced it correctly. In the United States, I have to say Aubert, otherwise you get some really strange spellings of it. My name is Daniel Aubert. I got 23 years with IBM. Interestingly enough, my mom, dad, and brother all worked and retired, so we're getting close to 100 years with IBM combined, which is crazy. I run a DevOps team in support of something called Cloud Pak for Data, which we'll talk later. But yeah, I've been involved with Turbo for a while now.
Excellent. And Daniel, thank you again, and congratulations on a century of IBM life. So that's quite an amazing metric to actual measure. As
it's
well,
actually really scary.
Yeah, exactly. And somebody who, if you have not met him yet or have not had a chance to see him present and share, both an amazing technologist and a great human, Mike Isaiah. Mike is from our Turbonomic team. Mike, if you want to tell us about yourself and your role in the IBM relationship as well.
Yeah, absolutely. So nice to meet everyone. My name is Mike. I'm a solution and innovation architect at Turbo, focused with our strategic alliances, in particular IBM. I've been working with IBM for a couple of years now. I've been at Turbo for about 5 years and very excited for the content that we're going to present today.
Now, as part of this, we've got a couple of different ways that we're going to share today. So the first thing we're going to kick off in just a moment is we've actually got a beautifully done video that's going to share exactly some of the work that's being done. This is actually Lohit's a star of this, so we're going to share a video that we're all going to watch together. And then we'll also get into a presentation, which is geared to be interactive. So it's a great opportunity for everyone to participate. So Daniel's going to share some content with us. And then we'll really just talk about the beauty of what we call a 1 + 1 = 3 opportunity for all of us, both as Turbonomic, as IBM, and everybody who's even not yet a customer of either. Hopefully, if you're watching live, you'll get a chance to meet up. And of course, all of this content's available on demand after the fact. We'll also share links to the videos in case folks don't get a chance to catch them all live here on the session. So with that, Chris, if you want to kick off the video, and we'll get rolling.
My name is Lohit Tyagaraja. You can call me Lohit. I'm a senior technical staff member, a master inventor, and a senior cloud architect working with IBM, GTS, Red Hat Center of Excellence. In this session, I want to share some of my experience around the evaluation and the experimentations that we did with Turbonomics and OpenShift. So before I share my experimentation results, I want to quickly set the context and the background of it. In today's world, most of our customers are adopting microservices and containers as their primary deployment models. And as more and more customers adopt, containers. We also see a lot of challenges in terms of the complexity of managing this platform, in terms of the security management, performance, SLAs, as well as workload consolidations. I was working with one of the client who had a requirement of deploying more than around 7,000 microservices in their environment, that too stretched across multiple zones. You can imagine how complex the environment can quickly become. So in this scenarios, we certainly need certain intelligent workload management to effectively manage this distributed cluster. We also have a requirement that customers expect every time their workload runs on a compliance nodes, right? This is because they want to ensure that the systems are always secure. Now think about a scenario. If I got around hundreds of nodes that are running with thousands of containers that are running, how do I determine which node is in compliance and which node is out of compliance, right? And I need these evaluations to be done in real time. Similarly, when we are managing such large cluster environment between your production, development, and your test environments, imagine the complexities that comes in configuring the required compute resources. Most of the times, a DevOps engineer may not even know the compute resource requirements of an application or a service. So he may statically go and define, say, I need 2 vCPUs or maybe 8 GB of RAM for that. But the question arises, is that a well-defined value or is that the desired value? Right? So those are the kind of challenges that will creep in as we see large number of customers adopting the container platform itself. So what typically happened is we took this as the challenges and we wanted an intelligent workload management that complements the native Kubernetes cluster as well as the container platform itself in order to provide this quality of services. With Turbonomics being the solution to provide the much required intelligent workload solution, what we defined or what we really wanted to achieve are the various business outcomes, right? So in terms of how do I achieve the workload consolidations, primarily to drive the efficiency? How do I ensure my nodes are always in a compliant state, primarily to address the security needs? How do I ensure that I provide more quality of services in terms of adhering to the SLA itself? That's primarily the performance that we are talking about. And last but not the least, how do I ensure that it provides me a return of investment in terms of the licenses that could be reduced or the issues that could be quickly resolved in order to provide a better business continuity? So these were the primary business outcomes with what we started this experiment. And what we saw as part of this evaluation is that Turbonomics was pretty much giving us the required business outcomes. Now, the first experiment that we did was in terms of efficiency. So when we started off this efficiency evaluation, we had a series of applications that were running across multiple worker nodes. For a period of time, what we observed is that Turbonomics was very clearly able to articulate or give us recommendations saying that you can now move the node or pods from one node to another node so that it started the consolidation aspects. What it did is it started providing the right amount of resources for the services that are running by continuously analyzing and at the same time consolidating the workloads as well. When it came for the second experiment around the performance, Turbonomics started giving a much better recommendations. In terms of as we induced a lot of load on the system, what we saw is Turbonomics identified how much compute resources like the CPUs or the memory that was required depending on the application execution itself. So it started analyzing the incoming requests, the executions that it was doing, and then started recommending that it's time for you to now provision additional compute resources so that the SLAs and the performance benchmarks was always maintained. And the third experiment that we did was around the compliance. So what we did is intentionally we made some of the nodes to go out of compliance. right? For example, we switched off one of the scheduler that was running on the node, which made the node to become out of compliance. And within no time, we could see that the Turbonomics was able to give me that recommendation and an action saying that this particular node is out of compliance, but you can move this pod into a different node so that it's always in a state of compliance. And the fourth one that I particularly like is about the full stack visibility that Turbonomics was able to give. A consolidated dashboard that showed me the application execution in terms of its performance, in terms of its compute resource consumption versus the complete stack, not just on the OpenShift aspect, but also on the VMs and a whole lot of other applications as well. All in all, when we ran these three experiments around efficiency, security, and the performance aspects, we could see that they were catering to the whole lot of business outcomes that we initially defined as well. Then we wanted to identify what kind of improvements that the Turbonomics brought to the table, right? So if you remember about the business outcomes, right? So what we did is we outlined the metrics associated with each of the activity that we did, and we certainly saw a good amount of benefits that the Turbonomics was bringing with respect to the OpenShift management itself. The first one, what you see over here on the slide, is with respect to the automatic consolidation of the workloads. Net, we saw close to around 20 to 40% of the efficiency improvements, right? That was in terms of where Turbonomics was suggesting that you can typically turn off 2 compute nodes because of the consolidations that we did. And the second one was around managing the dynamic incoming requests. So in this, we certainly saw a benefit of around 25% to 30% in terms of how Turbonomics was able to suggest the amount of the CPU and the memory that was required in order to ensure the application performance was always maintained. The third one was around the mean time to resolution and the mean time between failures. I would say that this was one of the most important aspects because we saw a typical efficiency of around 15 to 25%. So this was based on the recommendations that Turbonomics was able to provide, and what we observed is that the Turbonomics was able to give us specific recommendation in terms of go to this particular pod and move this pod to this specific node. Right? Now, as a DevOps engineer, when I see this recommendation, all I need to do is take an action. So I'm going to save a lot of time in terms of the resolutions itself. And the fourth one was around the reduction in the software and the infrastructure license cost. I would say like we observed close to around 20% of efficiency. And the reason why I say that is, let's imagine a situation where I'm running around 10 nodes. And because of the Turbonomics recommendation, if I'm able to shut down at least 2 nodes, I'm going to save on the VM cost, the node cost, and a whole lot of other softwares that runs on top of that particular node itself, right? So that's how I would call that as an efficiency in terms of the software and the infrastructure licensing. Last but not the least is always about the number of the full-time employee savings that we do, because when Turbonomics was recommending a particular action to be taken, it could be around performance, it could be around security, it could be in terms of your workload consolidation. The action is already defined. That means as a full-time employee, I will now spend less time in order to, one, find out the issue. And when I got lesser number of nodes, that means the incidents and the tickets that gets generated is also reduced. That will directly transpire into the number of people that are required to manage this cluster as well. So that I would put it across at least around 100 to 160 hours of saving in terms of managing the nodes itself, right? So effectively what we observe is that when I started using Turbonomic with the intelligent workload management that Turbonomic was able to do, I could see a whole lot of efficiency in all these areas or the domains that was very critical in managing the overall OpenShift cluster itself. And now with IBM and Turbonomic entering a commercial agreement and partnership where we can now position Turbonomics as the key workload management which complements the OpenShift deployment, I would think that it would be a pretty good inclusion as part of our container management solutions that we do with our customers going forward. Now, in this push-to-prod event, considering both Red Hat and Turbonomics are both here, if you have any questions or queries with respect to managing any kind of this workloads or on the container platform, please stop by at the respective pods and ask any questions or queries if you would have.
Excellent. Now, the only thing that could be better than virtual low heat is that we have real low heat here as well. And part of why we chose to do this as a video was just in case, because we want to always be respectful of everybody's time. And so I have to give an additional thumbs up to low heat. As well, I got to shout out to I'm very proudly wearing my iHeart IBM AI. And so I said the only thing better than IBM's AI is when it's beautifully wrapped in the warmth of Turbonomic. So together, we're a fantastic set of partners, and I've been very proud of the work that's been done by our teams. Lohit, you covered a lot of both tangible and intangible benefits in your presentation that we saw. Do you want to talk about your feeling? And this is important, I think, because we talk about DevOps, we talk about moving push to production. We use data to drive decisions, but the confidence that comes from that is what makes us as DevOps engineers, as SREs, more likely to be able to adopt new technologies and see those benefits, which then ultimately are self-fulfilling because we're now using automation to eliminate the unnecessary work that's being done. And then we see it proven out. And in fact, it's just such a beautiful benefit. So Lohit, you want to talk about your, both the human aspect of what you experienced as well as the systematic one. You're still on mute at the moment as well, just in case.
Yeah, thanks for reminding. Yeah, so in my experience, right, so I have been a DevOps engineer and a DevOps architect for quite some time. And I was also managing a lot of L3 issues, right? What we call as the level 3 engineer to resolve a lot of issues. Now, I know the pain that is involved even to find out where the problem happens, right? And when you're doing all these things manually, the amount of time that you take to resolve will have a direct impact on the business itself, right? Now, when I started my journey with OpenShift, that's a year back after the IBM's acquisition, of course. Now, it was a great challenge for me as well to understand the technology and then apply it in my real customer scenarios, right? Now, as I saw the containers growing, as I saw the clusters growing, now one of the need was I certainly had or wanted to have such intelligent management systems. One, to ensure that it pinpoints where exactly the problem is, and also gives me recommendation on how to resolve that. Now, as a DevOps engineer, if I got these two things, what it means is I can solve problems much quickly, right? And that will directly result into my business continuity so that I can ensure my applications, my infrastructure are always up and running. So for me, the kind of recommendations that Turbonomic gave me in some specific scenarios and the actions it allowed me to take, I think that's something as a DevOps engineer, it will be like very useful.
And you brought up a great point, Lohit, about the idea of continuity and availability are the state of business today. Whereas we used to think of node up, node down was success or failure, versus today we have to really truly think about availability, and cost and compliance are a significant part of that, where if you are overspending in order to add supply to it, it's a veiled attempt to try and give performance, but we've seen it both in your experience and ours in
Yes.
thousands of customers, literally, that it's borne out in the proof that throwing resources at it isn't necessarily the method. It has to be the right resources, and that's where these decision automation becomes an important part. As well, you talked about your history and experience. A lot of folks who are using OpenShift or using Kubernetes, in various forms, they often ask, how does how does Turbonomic differentiate versus Kubernetes? Because Kubernetes has its own native scheduler. And what we've found on the Turbonomic side, of course, is that it's not just an initial. So Kubernetes and OpenShift out of the box do a great job of initial placement, but that
Yeah.
doesn't account for that ongoing, health. So it's based on failure of either nodes or pods or containers or app services. And then on top of that, you talked about the net benefits of efficiencies over continuous operations. So if you wanted to sort of tell your story of how you saw this differentiation play out versus OpenShift, which is fantastic. I
Yeah, yeah.
certainly don't want to downplay the capabilities, but that's why this 1+1 = 3 is so apparent when we see these two platforms work together.
Yeah, so for me, if I want to just put it in one word, right? So for me, like Turbonomic was more proactive, right? It is in terms of like identifying a problem can happen as it is happening, right? Or potentially it can happen. Now, in some of the scenarios where I saw that like as the application demand increased, I know like I was getting low on memory. If it had continued with the same demand, no doubt OpenShift will spin up new pods and new containers. But now if I exhaust the capacity of my pod's definition itself, then the question comes up like what happens next, right? So there will be a threshold even at the OpenShift level, because for me, it's more like a reactive that the Kubernetes layer or the OpenShift reacts. But Turbonomics, on the other hand, as it starts analyzing the incoming data, specifically in the real time analysis that it does, and provides those capabilities or provides those recommendations about you're about to go into exhaust, or this particular node is out of compliance, right? Or you need to go to this particular node so that you're better compliant. So this is more of a proactiveness and real-time intelligence analysis. I think these benefits are well and above what Kubernetes as a platform provides to me.
Excellent. Thank you. And Daniel, this is a great time to make the transition. We're going to bring up a presentation, and you can do this interactively with us. But before we get started with that, I'd love to get your thoughts on, what Lohit has just talked about here, and your experience as well in your role.
Well, I'm going to underline a lot of the things that he said, real world examples. And there's a couple of key points that he made. Proactive approach to this instead of a reactive approach. There's a problem that I must go solve, as opposed to getting data about a problem that's solved, potentially in the future. The concept of the autonomous cluster is another idea that I'm so passionate about, is enabling the recommendation engine to actually take action. You could essentially set up your infrastructure to where it is self-healing and self-managed. And where I'm coming from a development perspective, being able to do that, the product I'm going to talk about is very young, so it's got a lot of issues. And imagine if I could say, the problems I'm having during development, I can count on the fact that it's not going to be an infrastructure related problem, that the infrastructure is going to be stable. And if something's wrong, it's with the code. Right now, we have to go make that determination. And that takes time and resources and all kinds of other things. So we've got some great examples in the presentation to back up what Lohit said.
Well, it seems like a beautiful, it's like you've done this before. We actually transitioned beautifully. I'll actually share the presentation off of here. And so please do tell me to move ahead as needed. You're seeing it on screen right now. So Daniel, we will start with the intro because it is good sort of to revisit. You've got a wealth of experience. So with that,
well, what this slide says is I have too many jobs. and when we talk about efficiency, that 100 to 160 hours that Lohit talked about, I've got 5 jobs and my engineers have 5 jobs. And if you can bring efficiency, and let me tell you something in this marketplace, anybody who has experience in DevOps know, you never get less responsibility. You always get more. And the only way to absorb the additional tasks and responsibility is with efficiency and automation. So that's where Turbonomic comes in to make such a big difference. And we'll go through that. But what I'm trying to highlight here by showing you my signature is I have more jobs than I know what to do with. Let's move on to the next one. So this is kind of our scope, and I've highlighted in red where Turbonomic makes a difference to my team. We're involved with development, we're involved with production support. We actually have a team of network engineers who support the whole data and I SaaS networking infrastructure. We do security and compliance. We're in the middle of a SOC 2 audit right now. I mean, these are all the same engineers that have to do all of these things. So how do I do that better? Let's move on. So Cloud Pak for Data is what we support. And Cloud Pak for Data is a relatively new offering in IBM. It's a premier offering in IBM, and it's designed around collecting, organizing, and analyzing data and infusing AI into your organization. IBM's making a big bet on it, things are going really well so far. Anybody who's interested in that, you can Google Cloud Pak for Data experiences, and you can walk through the production environment that my team supports that gives you a guided tour of the product. Just so you guys know, Turbonomic sits behind that environment, and that's where we did our POC POV is on the experiences environment itself. So you get a chance to see Cloud Pak for Data running with Turbonomic behind it, which is pretty cool. All right, let's move on. Hey, Mike, I'm going to ask you to chime in just to give you guys some background. Mike and I have been working together for about 2 years now and have been kind of in the background supporting the initiatives at IBM. We got together to do a POC in 2018, and we've remained engaged and involved in this ever since. And I'm certainly passionate about what it does for my team and my scope, as I mentioned before. I don't have enough time to do everything I need to do in the day. So when I come across something like this, I get excited about it. Let's go through these. Performance optimization, avoiding outages, and my passionate #1 priority here is data-driven decision-making. Are we making decisions with data, or are we guessing, or are we using experience? I'll give you an example. A DevOps engineer sleeps well at night when he's over-provisioned by 50%, and he knows he's not going to run out of capacity while he's sleeping. That sounds great to the DevOps engineer, but the finance person doesn't like that very much when you're running at double capacity to what you actually need. Imagine if you had infrastructure to where it would self-adjust to workloads as they're happening with the ability to add resources as needed. So, performance optimization has a bigger scope than that. And, we've already talked about full stack visibility. We've already talked about container sizing, etc. So that's the dream. And I keep talking about the autonomous cluster is where we want to end up. Management simplification, workload redistribution. We've talked about this, getting the recommendation engine to do some of this work for you. In the last slide, we won't go there yet, but one of my engineers talks about what he has to do to perform the same operation that Turbonomic can perform in a click. He's got to log into a jump box. He's got to log into the master node. He's got to issue commands to do it, as opposed to checking a box and following the recommendation, which is huge. Take that efficiency and multiply it by 10,000, and you start to see why engineers are excited about this as well. Mike, do you want to add anything? I want to make sure I don't miss anything.
No, I think you highlighted, some important aspects here that kind of reiterate what Lohit was describing, right? In particular around management simplification. And really at the end of the day, I think one of the biggest business outcomes here is developer productivity, right? If we can remove any resource contention or performance issues from the infrastructure, as we'll kind of demonstrate throughout these slides here, you're able to focus on delivering business critical functionality and services to your customers.
So let's move on to the next slide, but I'll just give you an example of that. You know, we're running anywhere from 40 to 60 clusters. These are OpenShift clusters with Cloud Pak for Data on top, installed on top of them for SRE evaluation and performance. And there's an underlying infrastructure issue that we had to resolve. As we've scaled up to more and more, the infrastructure got more and more taxed and adjustments had to be made. So during that SRE, during that continuous delivery cycle, you're starting to identify problems with the product, and that gets submitted to development. You guys, these are key points to why I think this is such a valuable piece of development infrastructure. So these problems get reported to the development team. The development team stops what they're doing in development and goes and tries to diagnose problems that may be because it's infrastructure. When I first started talking about Turbonomic, imagine if you didn't have to consider the infrastructure as an issue. With Turbonomic running and the automation fully enabled, and you have that concept of an autonomous cluster. That's a dream situation for development, and that's kind of what Mike touched on. This slide kind of
I'd just like to add, if I can add one more point, Daniel. I think it's important to also understand the flexibility that we're talking about this value in, right? So what you're looking at is all different types of examples of hybrid cloud architectures, whether it's running in a virtualized environment on-prem, whether it's running in a public cloud, or whether it's running on bare metal. And I think that speaks to the portability and aligns with the value of OpenShift on being able to run your mission critical applications wherever the best possible place is, and having the ability to bring this value on top of that as well.
Thanks. You summarized this slide perfectly. We can move on. So let's move on to a real world example of how Turbonomic saved my behind. Go ahead and move on. Cloud Pak for Data experiences, which I described earlier. It's your chance as an outsider to come in and use Cloud Pak for Data without spending any money, without talking to a salesperson, without doing any of those things. You can come in here, get provisioned out onto a real cluster that my team manages, and go to it. So what Cloud Pak for Data experiences means to IBM and to the customer is this is a customer's first taste of Cloud Pak for Data. It has to be perfect. You can't have any issues with this because a customer will get a bad taste in their mouth. So we run this as what I call super production. Let's move on to the next slide. So we had a situation where we identified a delay in login and some issues with some pods. And God, I'm not expecting this slide here. Can you move on to the next one?
Yeah, actually, just build it out.
Yeah, there Perfect. It is. Okay, that scared me. Go back one. There you go. That's everything. I'm not used to the fancy rollout of this stuff.
But you see, you were great, Daniel. This is how we respond to dynamic changes in our environment.
I was being dynamic. So basically what we found is Turbonomic identified a problem where the memory was maxed out. And if you look on the next slide, you'll see that it recommended the resolution, and you click the button and you're done. So what would my team have had to do if Turbonomic wasn't in place here? Would have had to go out and do that analysis itself and take those actions itself. The next slide actually shows the button you can click or fill this one out. There you go.
Perfect.
There you go. Scale up the vMemory for that container. Bam, you've solved the problem. Imagine what I would have had to do. And remember, I have customers out using this environment, deciding if they like Cloud Pak for Data or not. And the time it takes me to resolve this issue can affect somebody's opinion of the product. So take that mindset into any production application, and there's no room to play around here. Mike, anything else?
Absolutely, I think. Yeah, just to add a comment, right? So we talk about the current state of operations today, common practices, monitoring, and thresholds. And really the point to emphasize here is what to do about of performance degradation, or as Lohit described, how to prevent that performance degradation from ever occurring and resulting in a poor user experience. And so not only is Turbonomic's application resource management engine providing the analysis for what to do, but more importantly, also provides a automation mechanism and a policy-driven control mechanism to automate these actions so that you have this continuous optimization running as demand fluctuates and delivering a service quality that we can expect.
So in a perfect world with the automation enabled, this action would have been taken autonomously, and I wouldn't have even noticed the problem, because as soon as the problem happened, it would have been resolved. And I would have found out about this in a log instead of someone calling me panic saying, oh my God, it took me 20 seconds to log in, right? Let's move on. Oh, I think you have to play this out. There you go. Yeah, there's some bells and whistles in this presentation that we haven't seen in a while. Let's go ahead.
So in my experimentations, right, I certainly used Cloud Pak for data. So that is how I was able to induce a lot of load on Turbonomics to get those kind of results and experimentation.
And I think I installed those for you, didn't I?
Absolutely.
Yeah. All right. So yeah, we're connected.
Yeah.
I mentioned earlier about capacity and this concept of flying closer to the sun. You know, when you're on the hook for super production and you want a level as a DevOps engineer, you want a level of comfort. What that meant in the past was over provisioning. You know, I look at something where I've got all this extra capacity and I say, wow, no matter what happens, I'm going to be okay. And again, that's great for the DevOps engineer, and it's awful for finance because the cost can literally double, easily double. So if you have a well-managed environment, it allows you to fly closer to the sun with less available capacity, with the knowledge that if you need more will be provided quickly. With the automation enabled, more will be provided automatically, right? So when you talk about cost savings, it's important. When you talk about DevOps responsibility and stability of the product, this all makes a huge difference. So not only are you getting the efficiency, but you're getting some cost savings as well. Mike, do you want to add anything to that?
Yeah, I think just to add some color commentary to the slide itself, Eric, I don't know if there's a build out of this, but the black line that you're seeing in the middle there really represents when we enabled some automation within the environment. And what you're seeing is the peak resources for memory and CPU start to converge and actually decrease. And so by enabling the automation to continuously run, it enables for more workloads on the existing infrastructure or to get a better density out of that infrastructure that you're using.
And you can see the 20% over provision. So I never got over 80% utilization. So that 20% would be paid for and never used.
Great.
Finally, this is a quote from one of my guys, and he's talking about what he has to do to mimic what Turbonomic can do with a mouse click. And he's got to log into a jump box. He's got to log into a master node. He's got to go through bash. He's got to do all these different operations to get something done. When, you know, this is either production or it's development. Either environment, the efficiencies here are huge. And the DevOps engineers appreciate this because, like I said, they always have more to do than they have time to do. And the more automation and the more reliability you can get out of this infrastructure, what Turbonomic provides is it absolutely shows value. And on top of that, you get some cost savings to boot.
Yeah, just to add to this, so I think, you know, we talk about executing and accepting the actions. It's important to note that these actions can be executed manually from Turbo. We can also integrate with your CI/CD pipelines to understand what your deployments are and what the proper mechanism is for scaling out services based on demand. So a lot of flexibility in adhering to, you know, whatever technology and or however advanced you are in your app modernization journey today.
I'd like to add one last thing. For Cloud Pak for Data, we're talking about the Cloud Pak for Data appliance as well. the concept of an autonomous box that you buy. You know, if you're the NSA with the government, you're going to buy an appliance and you're going to put it in a deep dark dungeon somewhere, and it's going to run down there and no one's going to be allowed to touch it. By setting up Kubernetes, setting up OpenShift with Turbonomic, essentially you could create an autonomous appliance, and that autonomous appliance would have its own virtual DevOps engineer watching it and taking action proactively, right? And that's exciting stuff to me. Absolutely.
Well, and just one thing to add as well, Daniel, and thank you. This is it's such a powerful, set of real objectives that have been achieved, and it's anybody that's looks at Michael's day there, right? Like, what does it mean to try and deal with this problem? We all know this, right? I was a keyboard jockey for many years, 20 plus years in financial services, doing systems architecture and operations. And I know that, anything that I could do to reduce, like you said, you never automate yourself out of a job. You automate yourself into a really good job. Because what I want you and Lohit and Mike and Michael doing is architecting tomorrow, not troubleshooting today. And that's really where the focus needs to move.
Yep. And there's so many things on a DevOps engineer's plate that don't involve what we're talking about in this scope, right? And those things, working with people and securing funding and solving problems with development, being involved in troubleshooting code and all the things you do in a DevOps engineer's life. That's the stuff that you really need a brain to do. And in this case, recommendation engine enabled with automation, you can take a lot of that extra work away.
It's actually interesting. There's a study, something called More of X principle, that talks about where automation and AI potentially can unseat human effort. And this is the area where we love that it can unseat that. Because like you said, Daniel, there are things that are purely human past tasks, and we have to put attention to those because they aren't getting dealt with. People talk about technical debt. It's actually not the technical debt that's the problem. It's the everything but the technical debt that is really financially and business critical in what we do. So Lohit as well, I'd love to call on you. You having worked in this environment, and you and Daniel talked about how you work together to kind of stand up the environment. How did your experience match your expectations when you walked into what you believed that Turbonomic and OpenShift could do together?
Yes. So, okay. So my experience, right? So when I started off with Turbonomic, honestly, I didn't know about like what are the key capabilities of Turbonomic at all. But I had a problem that I was actually facing, right? So whenever I talk to the deployment of OpenShift, especially in a multi-cluster, or when I talk about like huge amount of nodes being part of the cluster, and we are asking the developers not to worry more about the infrastructure and saying that the platform will take care of it, right? That always was a nightmare for me, right? And when I was with some of the customers, when they say that now I'm going to deploy around 5,000 containers on my cluster, it really made me think that, okay, if that's a huge number of containers you're going to run, how am I going to even manage all the nodes? How am I going to manage the compute resources? How do I know where the problem will come? I know like there are like this monitoring aspects that OpenShift and Kubernetes provides, but how do I get a complete visibility of the stack? So these were all the pain points or the problems that I had in mind. So when I got involved in Turbonomic, saying that it has this intelligent workload management, primarily where it gives you or tells you what is your desired requirements of compute. Now that really became one of the interesting point for me to say that, okay, let me now start experimenting because this resonates well with the kind of problem I'm facing, right? Now, as I started installing, I had initial hiccups to install because I was trying to understand that. But once I installed that, that's when I had to rely on Daniel to give me the kind of workloads, right? Now I'm talking about a large cluster over there. That means I need to have big problems so that I can see like how Turbonomic actually helps me in that. So my experience in that, like as I started seeing the results coming in, the recommendations coming in, it was just like a click for me, right? So I had to just go, it says a recommendation, click on that, I go to that pod. Oh, I see that this particular compute resources is a constraint, right? And all I had to do was start increasing the compute resources and see the problem was resolved, right? So that's been my real life experience of using Turbonomic, because that's the experimentation and the evaluation that we did across some of these use cases.
Awesome. Awesome. Thank you for that. Daniel, if I could call on you for a question. I think, you have an interesting perspective in specifically being involved in the development side of things. If you could, elaborate a little bit on maybe what are some of the challenges that you come across managing fleets of OpenShift clusters with new builds that come out, and where you saw some value, or where you see some potential value for us to collaborate together going forward.
Well, I can tell you, the problem that I described when we were talking about, when you're in a fast-paced development cycle and there are issues with infrastructure, or there are issues with Kubernetes or OpenShift or whatever that's below the code, that can contribute to this horrible, vicious cycle of reporting problems that really don't exist, right? When you talk about code stability, that can be misinterpreted when it's running on infrastructure that's having problems. Or remember, when you're starting with an application, you're trying to size the application. They go out and do some computations or whatever. Running with Turbo behind it, you can get an idea of, under different workload, how an application is going to demand resources, and then include that into our sizing tool that customers go out and run, so they can properly size their environments when they buy the product. But when you go back to the development cycle, how many hours have been spent looking for problems that don't exist with code, or the finger pointing that happens between development and DevOps, right? Well, your stuff doesn't work. Well, oh yeah, well, your infrastructure doesn't work. So let's fight with data, right? Let's throw data at each other and fight about it. This is so powerful in that sense. We've experienced some growing pains, guys. I mean, most normal customer environments, the infrastructure at IBM on-prem, where most of the development is done, there's literally 8,000 OpenShift clusters running at any given moment. And we had a situation where when you install OpenShift out of the box, every 2 hours, it does a log reconciliation on the master nodes. And when 8,000 clusters all do a log reconciliation at the same time, that will bring the backend storage to its knees, right? And so people are seeing stability problems, and a new build came out right when that action happens, and they think, uh-oh, there's something maybe wrong with my code, right? So, this alleviates a lot of that uncertainty that would take a lot of research to find. And that's the exciting part about it for me from a development perspective.
That's fantastic. And it kind of lends itself back to, developer productivity and accelerating digital transformation, in particular within kind of the app modernization journey that customers are going through as they modernize their applications and bring cloud native applications to the market.
When we talk about technical debt, so technical debt happens when there are problems that you don't uncover during the SRE and performance test cycles, and they make their way into the marketplace. So when a customer finds a problem that you didn't find, and then you have to fix that as a Sev1 issue, what happens behind the scenes to that? Anybody who's involved with development knows that your top developers get pulled off the development work they're doing, and they get put into a support issue. So what happens to the timeline of the deliverables you have for the next release? Those get compromised. And if you compromise those, you may create this perpetual cycle where you're always trying to play catch up. You're not identifying problems. Problems are making their way to the marketplace and getting resolved in the marketplace, and you're always playing catch up. What if you could get ahead of that, right? Anything you can do to get ahead of that is going to make your product better. It's going to make your customers happier. It's going to make it less expensive to develop. I mean, we can go down the whole chain of the points we've touched on today. It's such a powerful thing. Look at Turbonomic as just a link in this whole chain, but it's an important link, right? It brings these efficiencies, and that's why Mike and I have been talking about getting this into development for 2 years for these very reasons, guys. That's the power of this.
Well, one thing to add to that, Daniel,
Absolutely.
and you talked about the value of the developer experience, and so I come from the ops side of the world traditionally, and so I'll call myself team underlay, and the automation continues below, and that truly is, in my belief, a developer experience, right? You shouldn't need to care about when it gets provisioned and how, and so ultimately, this decision automation now becomes not just code, container, pod, but now becomes node and physical layer and cloud layer, right? And so now we open up to interfacing with Ansible, interfacing with other third-party infrastructure as code and continuous configuration management. So what's your view on that kind of broader ecosystem and
Well,
where the opportunity is?
think about where Turbo sits, looking at the whole stack. Think about the environment. So we're multi-cloud deployment. So we may or may not own or control different layers of the infrastructure. We also do on-prem, to where we control the whole stack. I may end up with VMs, which I don't see below the VM, or with IBM Cloud and managed OpenShift, I don't even see below OpenShift in that environment, right?
Mhm.
And so you can just fit Turbo in at whatever layers you have and benefit from it. So the versatility of that in the multiple environments, because when you talk about Cloud Pak for Data, I have to support multiple versions of OpenShift. I have to support multiple storage classes. When Cloud Pak for Data is a platform, there's 30 or so assemblies or add-ons that go with that you can mix and match when you do your Cloud Pak for Data deployment. I have to test all of those possibilities. I have to have all of that available in development, not only to make sure that your code works, but your code works with everyone else's code on multiple storage classes, on multiple versions of OpenShift. So when you start piling all these variables in there, you start to see why I'm so excited about this, right? Is it solves a lot of problems, because when there's an issue with our software and something like the Portworx storage class, your DevOps engineers are going to be neck deep in that with no time to do any of this other stuff, right? And that's just one scenario. We deal with these scenarios all day long, 24 hours a day. So I love the full stack visibility. I love the adaptability to whatever cloud provider we're performing in, what we're testing in, and the benefits you get from it. That's the big deal from a DevOps perspective.
That's fantastic. So with that, I think, we did have one other video we wanted to show to kind of wrap up. But along those lines, very excited and proud to announce that Turbonomic and IBM have partnered to deliver an OEM of these cloud native capabilities in one of IBM's cloud packs, specifically multi-cloud management. So the link that Eric just posted there is where you can find some additional documentation on the architecture, and you can see how this capability and this value lends itself to not only cloud native applications, but also virtualized workloads and public cloud workloads. And there's also a blog post there for more details and information. So with that, Eric, I'll hand the floor over to you. Thank you everyone for the feedback, and tee it up.
Absolutely, it's been great. And as I set up this this closing video, I want to give a huge shout out again to Lohit and Daniel for sharing your thoughts today, and all the work that you and Mike and Enlin and Endra and Eva and all the other folks from we call them our E3 team. So it's Endra, Eva, and Enlin are part of our advanced engineering organization. You actually will see them. They're speaking and delivering. We were on a panel yesterday with folks and there's lots of other push to prod content. So of course, please do, if you haven't caught the rest of the activities today, please make sure that you check out the rest that's going on. I'm going to share this, and hopefully, fingers crossed, if my sharing, if the demo gods work, then you'll actually hear this. If you don't, please let me know. With that, in closing, thank you again to everybody for being a part.
Today, particularly in these challenging times, the application is the business. Even before recent shocks to global supply chains, more and more businesses relied on digital interactions. Indeed, analysts predicted that over 60% of all global GDP would be digital by 2022. The application has taken center stage. To meet the demands of this new digital world, enterprises are turning to IBM to enable transformation. Applications will need to be always on. They'll need to live on-prem, in the cloud, or in containers. In other words, be cloud native and able to thrive in a multi-cloud world. That's why IBM designed IBM Cloud Pak for multi-cloud management. To enable digital transformation at speed, IBM has accelerated customers' transformation by partnering with Turbonomic to introduce autonomic intelligence, analysis, and actioning to deliver full-stack application resource management, or ARM. To successfully manage in a multi-cloud world, you need to see all services at a glance. This enables operations to rapidly dive in to identify problems, incidents, and issues. Here, we see a number of instances across various cloud resources. Below, a list of applications depending on the agile execution, orchestration, and delivery of these resources. Let's take a look at just one of these applications, BookInfo. BookInfo is a cloud-native application running on Kubernetes. Displayed here with all the associated metadata, including security and compliance IT policies. Here, we can also see that BookInfo is encountering performance issues. BookInfo's response time has recently spiked over 3,000 milliseconds and seems to be struggling with an unexpected surge in demand. Looking at the ARM view, we quickly see the service is struggling. Shifting from a view of overall health to response time, we see a specific set of actions prescribed by ARM, outlining the need to provision new resources to enable this service to meet this spike in demand. More importantly, it outlines the need to provision new resources in a specific container pod, both to ensure performance of the application and avoid impact on other applications also using these resource pools. The ARM actions are detailed and specific, indeed with the specificity necessary to continuously automate for dynamic environments, while respecting security, compliance, and cost constraints, in order to reduce resource congestion, enable right sizing, and drive optimal resourcing, all while maintaining application response time within service level objectives. As seen here, in concert with IBM Cloud Pak for multi-cloud management, the actions are orchestrated with a single click in the IBM ARM interface. With these new resources provisioned, we see response time returning to service level objectives. In order to provide continuous SLO adherence, IBM ARM's intelligent actions can be fully automated, scaling application resources seamlessly, continuously matching resource supply with dynamic application demand, preventing performance issues before they impact end-user experience in the first place. IBM Cloud Pak for multi-cloud management with IBM ARM creates a single control plane, establishing a unified application operations structure, removing the silos between AppOps, DevOps, SecOps, ITOps, and SREs, while providing full-stack insight with visibility, control, and automation, freeing up critical resources to solve your business's hardest problems. A recent study demonstrated that IBM Cloud Pak for multi-cloud management, plus IBM ARM, drove a 45% reduction in time spent in manual activities, automating, scaling, load balancing, and capacity planning, a 34% reduction in tickets, a 15% increase in mean time between failure, a 25% faster mean time to resolution, and a 20% reduction in cloud and software license cost. IBM Cloud Pak for multi-cloud management combined with IBM Application Resource Management will enable operations teams to move from firefighting, waiting for issues to occur, to service control where applications are continuously and accurately requesting, using, and returning resources needed to meet their service level objectives. IBM Cloud Pak for multi-cloud management with IBM ARM powered by Turbonomic enables your IT teams to focus on the next generation of digital transformation to meet your customers' needs. Find out more at ibm.com/cloud/cloud pak for management.
Excellent. And so in closing, I can only say that let the skies be blue as well as the IBM logo. May your UI be green, and may the only thing that's red be your hat. Thank you again to all the folks today for joining us for Push to Prod. Please do check out. We'll have continuous, all the content's available on demand. Mike, Lohit, Daniel, everybody, Chris and Molly, who are hiding in the background, who are doing all the real work that makes this event happen. And to all the folks that have been attending today, thank you very much for spending the time with us. And we look forward to seeing you at an event again in the near future.
Thank you so much. Bye.
Thank you. Have a good day.